In Article 680 of the National Electrical Code, bonding together refers to the electrical connection between two or more conductive objects to ensure they are at the same electrical potential. In the context of residential electrical installations, bonding together typically involves connecting the electrical system's neutral conductor equipment, grounding conductor, and exposed conductive surfaces, such as metal conduit boxes and fittings. It also includes metal parts of the building, such as plumbing pipes, heating, ventilation, and air conditioning ducts, and structural steel. The purpose of bonding together serves several important purposes. Firstly, safety, as it creates a low-resistance path for fault current to flow, reducing the risk of electrical shocks and fires. Secondly, reliability. Bonding ensures that all conductive surfaces are at the same electrical potential, preventing potential differences that could cause arcing or other problems. Thirdly, code compliance. The National Electrical Code requires bonding together to ensure the electrical system is safe and properly installed. Now, let's address the situation with plastic boxes and non-metallic plumbing pipes. In this case, there may not be any conductive surfaces to bond together within the electrical system. However, it is important to consider the following. Firstly, grounding. The electrical motor is still required to be grounded, typically through the ground wire in the Romex cable. Secondly, appliance bonding. If there are any appliances with metal cases or frames, such as refrigerators or dishwashers, these must be bonded to the neutral conductor. Thirdly, local code requirements. Local codes may have additional requirements for bonding, even in situations where there are no conductive surfaces within the electrical system. It's always best practice to consult with a licensed electrician to ensure that an electrical installation meets all applicable codes and standards. They can assess the specific circumstances of the installation and provide guidance on whether any additional bonding is required. Bonding is crucial for electrical safety and preventing potential hazards. It is a fundamental concept outlined in the National Electrical Code. Understanding bonding requires careful attention to detail and adherence to relevant standards. When dealing with electrical systems, safety should always be the top priority. Incorrect or inadequate bonding can lead to dangerous situations. It is important to be familiar with the relevant sections of the National Electrical Code. These sections provide detailed instructions on proper bonding techniques. Proper bonding helps ensure that electrical equipment operates safely and reliably. It can also prevent damage to equipment and reduce the risk of electrical fires. When installing electrical systems, it is essential to follow the manufacturer's instructions. These instructions often include specific recommendations for bonding. Electrical systems are complex and require specialized knowledge. If there are any doubts, it is always best to consult with a qualified electrician. A qualified electrician can assess the specific needs of the installation and provide expert advice. Bonding is not a one-size-fits-all solution. The specific requirements for bonding will vary depending on the type of equipment and the environment in which it is installed. It is important to take into account all relevant factors when determining the appropriate bonding techniques. When performing electrical work, it is essential to use the proper tools and equipment. Using the wrong tools can damage the equipment or create a safety hazard. It is also important to wear appropriate personal protective equipment, such as gloves and eye protection. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself. Bonding is a critical part of electrical safety, and it should never be overlooked. By following the guidelines in the National Electrical Code, it is possible to ensure that electrical systems are properly bonded and safe to use. Now let's delve a little deeper into some key aspects of electrical bonding. Let's start by understanding the concept of electrical potential. Electrical potential is a measure of the electrical potential energy of a charged particle at a given point. In simpler terms, it's the amount of work needed to move a unit charge from a reference point to that specific point. When two conductive objects are at different electrical potentials, there is a voltage difference between them. This voltage difference can create a risk of electrical shock if a person comes into contact with both objects simultaneously. Bonding equalizes the electrical potential between these objects, eliminating the voltage difference and reducing the risk of shock. The National Electrical Code specifies the methods and materials to be used for bonding. These methods typically involve connecting conductive objects together using bonding jumpers or conductors. The size of the bonding jumper or conductor is determined by the size of the circuit conductors and the type of equipment being bonded. It's crucial to use the correct size bonding conductor to ensure that it can safely carry fault current. Fault current is the current that flows through a circuit during a fault condition, such as a short circuit. If the bonding conductor is too small, it may overheat and melt, compromising the integrity of the bonding system. The National Electrical Code also specifies the types of connectors that are approved for use in bonding applications. These connectors are designed to provide a reliable electrical connection that will not loosen or corrode over time. It's important to use approved connectors to ensure the long-term integrity of the bonding system. In addition to bonding conductive objects, the National Electrical Code also requires grounding of electrical systems. Grounding is the connection of the electrical system to the earth. Grounding provides a low impedance path for fault current to flow back to the source. This helps to quickly trip the circuit breaker or fuse, de-energizing the circuit and preventing a dangerous buildup of voltage. Bonding and grounding work together to provide a comprehensive electrical safety system. Bonding equalizes the electrical potential between conductive objects, while grounding provides a path for fault current to flow back to the source. When these two systems are properly installed and maintained, they can significantly reduce the risk of electrical shock and fire. Now let's discuss some common bonding scenarios. In a residential electrical system, bonding is typically required for the following. Firstly, metal water pipes. Metal water pipes can become energized if they come into contact with a live electrical conductor. Bonding the water pipes to the electrical system helps to ensure that they are at the same electrical potential as other conductive objects. Secondly, metal gas pipes. Metal gas pipes are also at risk of becoming energized. Bonding the gas pipes to the electrical system helps to prevent a dangerous buildup of voltage. Thirdly, metal appliance frames. Appliances with metal frames, such as refrigerators and washing machines, must be bonded to the electrical system. This helps to protect against electrical shock if there is a fault in the appliance. Fourthly, metal conduit and raceways. Metal conduit and raceways are used to protect electrical wiring. These metal enclosures must be bonded to the electrical system to ensure that they are at the same electrical potential as the wiring they contain. Fifthly, ground rods. Ground rods are driven into the earth and connected to the electrical system. Ground rods provide a path for fault current to flow back to the source. It's important to install ground rods correctly to ensure that they provide an effective grounding path. In commercial and industrial electrical systems, bonding requirements are often more complex. This is due to the larger size and complexity of these systems. In these systems, bonding is typically required for a wider range of conductive objects, including structural steel, metal ducts, and equipment enclosures. It's important to consult with a qualified electrical engineer or electrician to ensure that commercial and industrial electrical systems are properly bonded. Now let's address some common misconceptions about bonding. One common misconception is that bonding is only necessary in older homes with metal wiring. This is not true. Bonding is required in all electrical systems, regardless of the age of the home or the type of wiring used. Another common misconception is that bonding is the same as grounding. This is also not true. Bonding and grounding are related but distinct concepts. Bonding equalizes the electrical potential between conductive objects, while grounding provides a path for fault current to flow back to the source. Another misconception is that bonding is only necessary in wet locations. This is also not true. Bonding is required in all locations, regardless of whether they are wet or dry. Another misconception is that bonding is a do-it-yourself project. This is definitely not true. Bonding requires specialized knowledge and skills. It's important to hire a qualified electrician to perform bonding work. Incorrect or inadequate bonding can create a serious safety hazard. Now let's discuss some of the potential consequences of inadequate bonding. Inadequate bonding can lead to a variety of problems, including electrical shock, electrical fires, and equipment damage. Electrical shock can occur when a person comes into contact with two conductive objects that are at different electrical potentials. The severity of the shock will depend on the voltage difference between the objects and the amount of current that flows through the person's body. Electrical fires can occur when fault current flows through a high resistance path, such as a loose connection. The heat generated by the fault current can ignite nearby combustible materials. Equipment damage can occur when fault current flows through sensitive electronic equipment. The fault current can damage or destroy the equipment. In order to prevent these problems, it's essential to ensure that electrical systems are properly bonded. This requires careful attention to detail and adherence to the requirements of the National Electrical Code. Now, returning to the specific scenario with non-metallic plumbing and plastic boxes. It's understandable to question the need for bonding when dealing with non-conductive materials. However, even in these situations, there are still several important considerations. Firstly, the presence of metal appliances. As previously mentioned, appliances with metal cases or frames must be bonded to the electrical system. This is true even if the plumbing and electrical boxes are made of non-conductive materials. Secondly, the potential for future modification. Even if the current installation uses non-conductive materials, there is always the possibility that future modifications will involve the use of metal components. In this case, it would be necessary to bond these metal components to the electrical system. Thirdly, the requirements of local codes. Local codes may have additional requirements for bonding even in situations where there are no conductive surfaces within the electrical system. It's important to check with the local authorities to determine the specific requirements for your area. Fourthly, the presence of other metal objects. Even if the plumbing and electrical boxes are made of non-conductive materials, there may be other metal objects in the vicinity that need to be bonded. For example, metal window frames, metal door frames, or metal structural components. In these cases, it would be necessary to bond these metal objects to the electrical system. It is always a good idea to err on the side of caution when it comes to electrical safety. If there is any doubt about whether or not bonding is required, it is best to consult with a qualified electrician. A qualified electrician can assess the specific circumstances of the installation and provide expert advice. Remember, electrical safety is not something to be taken lightly. It is important to follow all applicable codes and standards to ensure that electrical systems are safe to use. In summary, bonding is a crucial aspect of electrical safety. It is essential to understand the principles of bonding and to follow all applicable codes and standards. If you have any questions or concerns about bonding, it is always best to consult with a qualified electrician. Now let's explore specific examples of bonding in different scenarios. Consider a swimming pool. Swimming pools are a particularly high-risk environment for electrical shock due to the presence of water and conductive surfaces. The National Electrical Code has specific requirements for bonding swimming pools to minimize this risk. These requirements include bonding all metal parts of the pool structure, such as the reinforcing steel, the metal coping, and the metal ladders. They also include bonding the metal parts of any electrical equipment associated with the pool, such as the pump, the filter, and the lighting fixtures. The purpose of bonding these metal parts is to create an equipotential plane around the pool. This means that all conductive surfaces within the pool area are at the same electrical potential. This helps to prevent electrical shock if a person comes into contact with two conductive surfaces simultaneously. Another example is in healthcare facilities. Healthcare facilities are another environment where electrical safety is paramount. Patients in healthcare facilities are often particularly vulnerable to electrical shock due to their medical conditions and the presence of medical equipment. The National Electrical Code has specific requirements for bonding healthcare facilities to minimize this risk. These requirements include bonding all metal parts of the building structure, such as the structural steel, the metal conduit, and the metal piping. They also include bonding the metal parts of medical equipment, such as X-ray machines, patient monitors, and infusion pumps. The purpose of bonding these metal parts is to create an equipotential environment within the healthcare facility. This helps to prevent electrical shock to patients and staff. Another example is in industrial facilities. Industrial facilities often have complex electrical systems with a wide range of equipment and machinery. The National Electrical Code has specific requirements for bonding industrial facilities to ensure electrical safety. These requirements include bonding all metal parts of the building structure, such as the structural steel, the metal conduit, and the metal piping. They also include bonding the metal parts of industrial equipment, such as motors, generators, and transformers. The purpose of bonding these metal parts is to provide a low impedance path for fault current to flow back to the source. This helps to quickly trip the circuit breaker or fuse, energizing the circuit and preventing a dangerous buildup of voltage. These examples illustrate the importance of bonding in different environments. Bonding is a critical aspect of electrical safety and should never be overlooked.